Okay, so I think we can start to our lecture for today's class because I would like to go faster because this is just my plan for today's class is basically reviewing the fundamentals parts for mathematics. So we are going to really back to when you first learn mathematics. Okay, of course not all section, but maybe just a slight review. Okay, so what the question is, last time I'm asking what is the building block of mathematics. Anyone maybe having some discussion or perhaps go through the website or maybe reading some books or maybe watching some videos about this. Any thought? Understanding of numbers. Okay, let me write here. Let me write here. Numbers. I think last week some student also say numbers, but any other ideas? Functions. Perhaps, but let me write that as a number 2. Okay. Okay. Anything else? Anything else? No. Numbers is probably an average answer for most people.
Connection of things.
Connection of things. I think I know what you mean, but let me just write that first, and I can explain what you mean. Okay, connection between things. Okay, so what I mean by building block is if we have like a set of, let's say this is matter. Okay, let's say like this table here. Okay. Of course, it has a building block. Like perhaps at the early day of science, we know that the matter probably having something called atoms, right? And atoms, in its own words, is basically something that is not divided, right, or indivisible. But then science evolved, progressed so far that we find the proton, electrons, even the quarks, leptons, and so on and so forth, and I think many of them, right? But that is for matter. But for math, if we say, let's say, let me write 4. If I say 4, what is 4? What is 4? Yes, you can say natural number, but you say number, but what is that? Right? I mean, if we go back to where we don't know what numbers, how do we explain things to maybe toddlers? Maybe using some. This is 4, right? This is 4. So you have 4, let's say, markers. And then maybe you have any other things that is 4 and you say, okay, that's 4, maybe let me just draw here. Just like explaining to like your kids or toddlers, like, okay, we have 4 circle or 4 balls. We have 4 square. And then like maybe here's the pen. And all is 4. And you can understand, because we know we can count that is 1, 2, 3, 4. So what is this? This is what we call sets. Okay? And of course, from numbers, if we learn the numbers, if they are within the same set, we can add, we can subtract, right? Okay? Got it? So what I want to going into details is we're going to set of numbers and kind of numbers, right? And we have, for example, we have the natural numbers, or we could start from the integer. Okay, so we have the natural, and then integer, the rational, and then the real number. And then the irrational number. Maybe irrational first, right? Irrational first, then real. And then we have something that we call the real numbers. Integer is like this, right? The symbols. The rational is like that. Irrational, I forgot the irrational. Real is this, right? Okay, or if we are going to make it into some set of universe of numbers. So perhaps we start from the natural numbers. We explain to the kids, toddlers, okay, we have something that you can count, right? That is on the real subject. And then we learn that, okay, what's happened if we subtract 1 with 2, so 1 minus 2, so it should be minus, right? But the concept minus is there because of we have the integer, then we have the negative part, and we have the 0, right? And then we have something in between, right? Something between 1 and 2, maybe we have half, 3/4, and decimals, stuff like that. We have the rational numbers. And we can have the irrational numbers. That its definition being is if we are trying to compute this, okay, we are going to have a lot of decimals, okay? Like almost infinite decimals, right? You can check with your calculators. Okay? It depends on your calculator's memory, right? How many? Yes?
Why is 46 rational?
46. Interesting.
Prove it.
Interesting. Interesting. There's something missing in the books. Let me check the books. Interesting. So perhaps maybe this is, I'm not sure what's happening with this, but let me just make a square and then remove that piece. Yeah, good eye. All right, but what we are going to focus is the whole thing here. The whole thing here that we called, this is the real numbers. Okay. There is one section that is going to be focusing on the not real numbers, or the imaginary, or the complex number, but that will be only on a few cases. Okay. And we can see that how we could line up all the numbers that is possible into this one straight line. Okay, so all the numbers, integers, the rational and irrational, they could fit within this line. Okay, and I hope this gives you just a brief idea on the construction of the mathematics. Okay. And then from the numbers we get the addition, subtraction, and then multiplication and division. And of course, And I believe everyone knows all the procedure and all the definitions, right? So I don't want to just repeat and just go for a quick review, okay? So let's go. Okay. I'm just curious, okay, just checking your math in a brief. So multiplication, just a few section here. So if I asking you to multiply by 1, okay, you know that this will be 2, right? But what is 2 multiplied by 1?
2 times 1.
So it's actually what?
1, 2.
It's repeated one time.
Yes.
It is repeated one time.
Repeated one time? Okay. How about this? 2 by 2 is 4, which means?
2 plus 2.
Yes, that's the idea. So multiplication is actually an addition, right? You get it? So it means that we are multiplying 1 plus 1, okay, it's 2, okay? Or we multiply this, 2 plus 2 is 4. Or if I say 5 with 3, it's 15, right? But 5, 3 is 5 plus 5 plus 5, 3 times, okay? And how about division? So if multiplication is an addition, division is subtraction, right? So if I say, maybe just take the numbers from the above numbers. So if I say that 15 divided by 5, this means that 15 is minus 5, minus 5, minus 5. This is having 3 times, right? So it should be equal to 3, right? And the same way, if we divide 15 with 3, this is going to be minus 3, minus 3, minus 3, minus 3, and it's not 3, sorry. It's supposed to be 0. And this one is the answer, right? So let me write here. It's 3. And this one is going to be 0 again, and this is going to be 5 because it's 5 times. So 1, 2, 3, 4, 5 times. Okay. Now, of course, you can also divide this with 0. What will happen? So one way to define why this is what we call it undefined is because what we are doing here is actually we are computing this, and how many n? Infinity or not? But since we're not sure, we call this an undefined. So it will not reach 0. And one way to get close to this form is by calculus. Okay. I was also surprised. Okay, with calculus through the limit. Through the limit. You'll learn in calculus class about limit. Okay. So it will not reach 0. So we call this undefined. Okay. Yes. Okay. Okay. Okay, now let's go to the sets and interval. So if we learn that the building blocks is sets, and what this sets means is this is collection of objects, and objects is the elements of the set. So if, let's say we call the S is a set, then we say A is an element of S. And sometimes we can also write to disprove this, like if we have B, okay. B, we are not defining B as an element, so we can say that this is not an element. Why is bad? It's not element of S. So we say B is not an element of S. So if we take, for example, if, let's say A, let me just give you numbers, like 1, 2, 3, 4, 5. Let's say we have 1 to 6, that is A. And then we say that A is equal to, usually we write the notes on the, within the, defining the sets. So X, as X is an integer. So let's say we define this as an integer. And the interval is from 0 to 7, but they are both not included. Or we could say include 1 to 6, but it will be also equal. That is also possible. Okay. So we say that A is a set of all X such that X is an integer and you can say that, okay. But I think the way we write these notes is like we utilize the mathematics as a language. So if you are being given the interval or the sets and they write some definition over it, you understand that is X is integer and the interval is from this. Okay. Okay. Okay, and then aside from what we have as sets and interval, we could also take those interval or sets with the union or intersection. So we can have many sets, right? We can have A, we can have B, C, D, or any variables or any symbols you want. And you could say numbers is like a symbols, right? And of course, we say like 1 plus 1 equal 2. It's become like we call axiom. Axiom is something that it is there, nothing no need to be proven. Something that is there, logics, and it's based on fundamental science. And we call it an axiom. Yeah. Okay. So union, or we say something like, we write a curve like that, like U, and we have the intersection. We write reflecting upside down the union. We call the intersection. So let me write, if we define S and T are, let's say they are both sets, okay? We say the union for both of the sets is S union with T. So what does it mean? It means that all the elements, okay, means set that consists of all elements that are in S or T. It means both. Okay, it means both. And then we have the intersection, which we can say S intersect with T. So this means, let me write here. It means that the set consisting of all elements that is common part of S and T. Okay, sometimes we can see, if you see these symbols, it means that it's an empty set. So nothing's here, so no element. Okay, so we could say, if this is the universe of the numbers or of the sets, then we could okay. Before we take some breaks, because we say that this in the middle is the intersection, and the union is for both S, T, we call this a union. Okay. Do you want to have a break? Do you have to have a break? Or no? I mean, that's up to you. If you want to continue, then we can finish early. Which one do you want? finish early or having a break? Okay. I also agree. But I need to ask you so that we have a consent. Okay. Let me just write some numbers and sets on the right side here, just to give you a quick example on how we are using this. So S 1, 2, 3, 4, 5, and we have T, which is 4, 5, 6, 7, right? And then we have another set that is V. V is 6, 7, 8. S union T, or SUT here, S union T. So I have S is 1, 2, 3, 4, 5. T is 4, 5, 6, 7. V is 6, 7, 8. Okay. Oh, by the way, I think some students get into class a little bit, a few minutes late. So they didn't see the groupings. Have you checked your numbers? Have you checked your numbers? Anyone up there? Maybe you can just come from and just take photo. Okay. Your name here? Have you checked your name? Number, sorry. Group 3? Okay. Okay, anyone else? Not having any groups? Okay. Okay, so that means I think everyone already have now. Okay, let's go here. Okay. Now the S union T. Okay. Anyone from group 1? Can you help me? Which one is group 1? The S union T. Someone from group 1 can help me?
1, 2, 3, 4, 5, 6, 7.
Okay, okay. I think it's too easy, right? It's too easy. But let's just refresh our minds for a while. Okay. So we say this is 1, 2, 3, 4, 5, 6, 7. Right? Otherwise. Okay. And then S intersection with T. Anyone from group 2? Group 2. Do you want to try?
4 and 5.
4 and 5. Okay, too easy, too easy. Okay. And how about the third one? The S intersect with T. Group 3. Anyone from group 3? Yeah, can you help? Yes. Empty set. Okay. So we could just write here. It's an empty set. Okay, now let's move on to the interval. Okay. The interval, let me just get all this down here, down here. Oh, wait. Make it a little bit small. Okay. Now, let me explain a little bit what we are going to do here. So in an interval, let's say we are going to have A to B. Okay, so from A to B, so A on the left and B on the right. So let me just graph this. Okay, A here, B here. Okay. So just to let you know that if we have this kind of, let's say, line number, if we would like to, let's say, making something like this, this is, we say, this is an open interval. And then this is the interval here. Maybe let me write, maybe change the color, sorry. Maybe change the color to red. Okay, so we call this an open interval. This is also open interval. So the implication of open interval is we are not including these two numbers. Okay? So if we see notations like this, A, B, with a bracket like this, with a curvy bracket, and we see the descriptions that this interval is A less than X less than B. In the line number, we see this kind of dot, okay? Like a white dot. So we say it's an open interval. Okay? And then similarly, if we have another set here, oh wait, it's missing. We say this one is closed interval. So we are going to include both A and B if this happens. Okay? And sometimes if we look on how we can write, we write with this rigid bracket, like a square, right? And then in the interval, we can see the description that A is less equal X. So X can be A. And then X is less equal B. Okay? And this is the description. Okay? Of course, this open and closed interval, we can also mix together. So we can have closed interval and then open. So close, open, or open, close, and in another line number, we can also take, for example, A and then to infinity, which means that this is basically saying that A is less than X, or X is greater than A. You can switch this to, and you can see the line number. You just go through here all the way, and just you can just end here, and then this is the arrow. And the same way, you can also make this into a closed interval, and you can see the line number like that. And also for the negative part, we can see from negative infinity until B, like that, open interval. And do the same way for the closed interval. And then the last one is just for all real numbers, which means this is start from negative infinity to infinity. Okay? Okay, now with the same principle, if you want to express terms, I think we can make it a little bit bigger. And I can zoom out a little bit. And let me just put here, make it smaller. Okay, if you want to express each term in inequalities and graph the interval, which means that we are going to draw the line number. For example, let's say the first one here is the A. We have -1 to 2, right? We need to include -1 and exclude the number 2. So let's say we are going to take, let's say 0 is here, -1 here, 2 is there. Okay. So we can, this is close interval. Why? Okay. Close interval and then open interval here. And then that will be our line. Okay. I believe you can do the same thing with number B, but for number C, let me just draw. So this is -3, or maybe let's say -3 is here. Let's say 0 is here. And then since it will be an open interval, so that will be the graph. Okay. Okay, easy, right? Okay, simple, right? And just to let you know that this line number, although that is very simple method, I think that will be very great method, because if you thinking on a calculus class, we are dealing with intervals, right? And sometimes we need to check the intervals. And the easiest way to do that is taking the line numbers. It's very simple, very subtle, but it's very useful. Okay, let's go to just another set that we need to draw. So we have the intersection and union. Okay. So I think group 4 and group 5. Anyone from group 4? Anyone from group 4? Can you try for A, number A? Number A is this one. I mean, this is it's asking to draw the graph, not the graph, the interval. I think too easy. Or I will just explain it quickly. But I hope it's still understandable, right? Still okay, right? Okay, I will just going quickly, and hopefully we can go further until until we reach something that perhaps not that easy. Okay, so if we take here, just one by one, let me just draw. Let's say I will draw each set. Okay, I will draw each one. So let me take different color. So this is, let's say 1. Let's say this is 3. Maybe 3 is here. And then we have another one down here. Maybe a little bit longer. And then this will be 2. And then let's say this is 7 probably here. Okay, so this is the first set. This is the second set. And basically, this is the intersection, right? Just to show you that. Okay. And then we can draw another one. So this is 1, 3. This is 2, 7. So what will be their intersection? 2, 2, 3. But which one we need to include? Okay. What is your answer? Yeah. What equal what? Yeah. Yeah. Yes, correct. Good. Okay, so this will be, let me go with green color. So this will be, we need to include 2, right? And then how about 3? Should we include 3? No. Okay, good. Because of we are having not any 3 within the first set, it means that we need also to exclude that. So 3 will be there. Okay. 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 So this will be 2, 3. Okay. And in the same way, we can take it for number B. So this will be 1. This will be 3. Okay. This will be accidentally undo the line. So this is 2. So maybe this is 7 here. Perhaps that is 7. So that's line. Okay. So this is 1, 2, 3, and this is 2, 2, 7. And the union means that everything we need to include from both sets, which mean, do we need to include 1 or not? No, right? So we need to open interval at 1, and then we need to include 7. Why the new updates for these good notes not really helpful? I prefer the old one. Okay. Okay. I think still easy, right? Too easy, right? No? Is it too easy? Too easy? Okay. Good.
Look at 3 counts.
Hmm?
Look at 3 counts.
3. Yes, count because it's on the second sentence. So it needs to include, right? So, right? Unless that is intersection, then yeah. Okay. Now, another important concept, which we call the absolute value. Okay. So absolute value. So if A is a real number, it's kind of funny. So let me just write some quotations over there. Okay. Then we say absolute value of A is, we write with this straight line, vertical line, and then by definition, A inside this absolute value brackets is a positive A if A is greater or equal to 0, or negative A if A is less than 0, right? So what's the implication? So the implication is that everything inside this absolute value, we are going to have a positive value. Okay. And sometimes these symbols also indicating the distance. If you are thinking in a system of coordinates or Cartesians, if you see some graphics, they mention it's absolute, you can think this is like a distance. Okay. So we can also think this like a distance between points on the real line. So if A and B are real numbers, then distance between points A and B on real line is okay. And I think you should be able to understand that part, right? Okay. As you see from this line, this real line, from -3 to 0, we call the distance is 3 because they are going to move from this -3, 3 units. 1, 2, 3, 3 units. Okay? You could think absolute value as a distance. Okay? The same way 0 to 5 is 5 units. Okay? Okay, we are going to move to we call the exponent. Okay. The exponent. Okay, exponents and radicals. I don't think this is helpful. Okay, so the first is the exponential notation. So if a is real number and n is positive integer, then the nth power of a is a with the power of n. It means that this is multiplied a until a, and this will be n times. Okay. Now this is what we call, the a is what we call, so let me write, a is the base, and n is the exponent. So it means that if we take 2 with power of 3, we mean that 2 by 2 by 2 is 8. Okay? So how about if we have a with power of m and an a with power of n? So a power of m plus n. Okay. Okay, and then I believe you agree that this is equal to 1, okay? And then if we have the negative n, this will be 1 over, okay. Just a quick review, and then I think everyone agree, okay? And this is some example and some law of exponent. So if you are maybe need to refresh an idea here. Okay, so if you have multiplication like this, it means that you are going to plus your power. If you have rational like this, division, then you need to subtract m with n, right? Okay. Okay, and then if you are having the power and then having another power outside the brackets, you'll have multiplication between the powers, right? Okay. And then you can also take the AB inside the power and then separate both of them between A power of n, B power of n. And the same way when you divide them, and then if it is reciprocal like this, you can reverse the numerator and denominator as well. And then this is the same thing, very same thing as that. So I think just a quick review of that. Okay. I think for the proving, I will leave that to you. There will be many tutorials, and if you want to try to review by your own. Okay. Okay, if I have Okay, how to simplify this? Basically, you see that we have x, y, and z, which means that we need to simplify those into only y, only one x, one y, one z, right? So we are going to take that into, for example, the first one. Sorry, it's not 3. It's supposed to be y, sorry. X over y. So this will be, let me write with the green color, x to the power of 3, y to the power of 3. And the second one will be, let's draw with this. And then what should we do? We are going to cancel out for some symbols that is the same. So this will be x with power of 3 plus 4, right? And then y with power of 8 minus 3. And then z is still with power of 4, okay? Anyone still having difficulty solving problems like this? Easy, right? Okay. Just checking. Okay. I will. There's some notes on scientific notation, but I think I will skip that. I believe you are going to need that on chemistry, right? And then let me go through the radicals. Okay. Okay, so if this is definition, it means that the b squared is equal a, and b should be positive, right? Okay, so what we call here, that this one here, this is a square root. This is a radicals. So if n, so if n is any positive integer, the principal and root of a is means that b with power of n is equal a. If n is even, then a is greater equal 0 and b also greater equal 0. Okay, and perhaps some of the property that might useful is we have at least 5. Yeah, at least 5. So this the square or the roots with n power. It means that we can separate these two with each of a and b. And the same thing with the a over b, we can also separate that. And if we have the roots, and then with another roots is actually we can have multiplication m n as roots, and it's actually the idea of roots, because of the definition, is actually similar to what we have in exponent. Okay, and then this is if odd, and this is if n is even. Okay? And these radicals we can combine the radicals as so if we take square root over 2 plus square root over 200, we could take this and then, and sometimes it's useful. So let's say 16 multiplied by 2. Why 16? Because we can have this perfect square root if we take the 16, right? And then 200, maybe 100, right? Multiplied by 2. It means that we can have 4 square root of 2 and then plus square root of 2, and then we have 14 square root of 2, right? Okay. Sometimes this algebra, although it's very simple, sometimes it will also maybe useful in the advanced process. Okay. Like if we take the 25, let's say b inside the radical, and then minus, we have b cubed like that. It means that 25 we can make it into 5, and then b cubed we can take b cubed as b squared b, right? So do you agree that we can make this like that? And then we can take 5 minus b square root of b, right? Okay. Okay, anyone still maybe having difficulty with the radicals? No, right? Okay. I just check, okay? Because sometimes you learn something like from basic, okay, and then maybe because not really smooth, or perhaps the understanding is not correct, and then you are maybe in the third year, or maybe the second year, the third year, but you don't have this fundamentals. So you are learning the integrals, blah blah blah, and then you arrive at the like certain level that because of you are missing some points, then you need to like reset all together. So I don't want that to happen because it happens many times. Okay. So if you are having troubles, difficulty, just please let me know. Okay. Okay, just a quick example. So if I take square root of 2 and then plus this, because we already see from here that we can multiply. So if I take square root of 2 plus square root of 2, what is equal to? Yeah? 2, yeah. 2 square root of 2, right? Okay. Because a few students answer this and then they give the answer 2. And that's happening in the exam. And because because that's why we have this course. Okay, we need to cover something like this. Okay? Okay. Another one is the rational exponents. Okay. So the exponent, radicals, to kind of combine together, and we call this rational exponent. And then this will be, I think generally we can combine the exponent and radical and just write with this. Okay? And this will be very, very general for all conditions. So we say we have the m over n as in our power. It means that the m will be the power, the n will be the roots. Okay. We can write the roots n of a with power n, or we could write a with power of n and then roots by n. That's the same thing. Okay? And then if that is, if the n is even, we need to require a to be positive. It means that we need to make sure what will happen with a if we change the n. So if n is odd, it means that it can be negative. Okay? Sometimes if you are maybe not really clear with something, or maybe you need to prove something, you can try some numbers. And sometimes you can try what happens if this is positive, negative, okay? All right, rational exponent. Yeah, we can start from the a with power of 1 over n, which is, this is the roots. And then from here we go to here. Okay. Let me just give you an example here. It means that a is power of 2 over 5 plus 7 over 5 minus 3 over 5. It means that this will be a with power of 6 over 5, right? Okay, just a quick example. And then another example using radicals. Maybe 2 first, okay. So we have square root of x. The square root of x squared of x. Okay. So what is this? So remember that we have square root, which means that this is power of half. Okay. So it means that this will be x. And then let's say this is x with power of half, and then this is half. Okay? Which means that we can multiply x with x power of half. It means 1 plus 1 over 2. It's 3 over 2. And then multiply 1 over 2, 3 over 5, 3 over 4, right? Agree? Agree? Okay, if you have some trouble here, your future will be in trouble. Okay, I just let you know that. So x, let me write step by step. So 3 over 2, and then with power of 1 over 2, this is x, 3 over 4, right? Okay. So you can imagine if we have the square root x and then Can you simplify this? I think you can, but it has just a long writing. We start from here, or maybe start from the very inside. Let me give you a couple minutes to see you. Okay. Because if I'm just giving you this, it's too easy. I'm giving you this. So I'm trying to increase the difficulty level. Okay. Do the same thing with this. This is very, very simple. From inside, half, okay, and x1, so x 3 over 2. So this will be, or you can say from this you can get x 3 over 4, so you get x 3 over 4 plus 1, right? So 4 over 4, 3 over 4, 7 over 4, 7 over 4 half, 7 over 8, right? 7 over 8 here, 1, 15 over 8, 15 over 8, 15 over 16. Okay. Hey, so slow, so slow. I didn't even do right. Okay, you need to think fast, and you need to find how to think fast. That's one way to understand, or maybe to solve math quicker. Okay. How to think fast? You need to see the pattern. Okay. So you need to recognize the patterns. Okay. So everyone agree? It's x 15 over 16. Right? Yes. Right. So it's just getting inside here. So x. This is x half, right? X half. This is x 3 over 4. So I have x 3 over 4, and then with half, this will be what? 7 over 4, right? 7 over 4, 7 over 8, right? 7 over 8, and then again x 7 over 8, and then half. So it's 8, 15, right? X 15 over 8 multiplied by half. This is 15 over 16. Okay? Okay. Okay, if you don't get this, then your level, in my opinion, still not sufficient. I must honest with you. Actually, I have like some questions like the advanced mathematics, but I will keep that maybe for a couple of weeks. Okay. Okay, now, okay, one more thing before we go to the algebra expression is what we call the rationalizing denominators. Okay? This is, you will find this in calculus as early as limits. Okay, if you learn limits, then one way to solve limits is rationalizing the denominators. Okay. So what is rationalizing means? So rationalizing is when we have 1 over square of a. This forms sometimes we are not in the final forms. Usually the final forms is we are going to make these radicals on the denominators, okay, to be removed. Okay? And how to remove this without exchanging the value. So to remove that, we usually just take square of a over square of a. And this will be equal to 1 over a square of a. Okay. And this is what we call, I think, the normal form. Usually we write in the final form in most of the fundamental sciences in this form. Okay. And this process is called rationalizing. Rationalizing. So this is rationalizing. So if we take 2 over square root of 3, it means that if we want to rationalize this, we are going to take this and then multiply with square root of 3, square root of 3. And we get 2 over 3, square root of 3. Okay? And then what if you take root 7 of 1 over a squared? How to rationalize this? Okay. Rationalize, because we focus on the denominators, then we need to make sure that we know which one is. So let's say this, because this is having the roots on all forms, then perhaps we can write, because it's only 1, so we could just write like this first. And then multiplying with the same numbers or value with the denominators. Two over 7. Oh, wait. Why this is 2? Should be 5. Do you know why? Because we want to make 1 over a. Okay, we want to make 1 over a. Because we want to make 1 over a. So let me write here. 2 over 7 plus 5 over 7 is a, right? So at the end, this is 1 over a, and then have the roots 7a with power of 5. But most of the cases, if we are looking forward in at least calculus or even engineering of mathematics, usually the case is just a square root. Okay? So you need just to multiply with its own numbers. Okay? But the idea of rationalizing is we want to make denominators without any variable. Okay, that's the rationalizing. Okay, any questions, thoughts? So the next part is the algebraic expression. So what is algebra or algebraic expression? What is it? Anyone can give some explanation, or what is the example of the algebraic expression?
You can go from the equations.
Yeah, equations, but what is the keywords? Eh? Yes, variable, correct. Variable. So algebraic expressions is an equation or expression that has what we call variable. So the keywords for the algebraic expression is variable. What is variable then? So it has a variable, but what is variable? Any idea? Variable? It can be something that you can put into, right? We call usually an x, right? And usually in the exam, find the solution for x or find x, and then the student just put an arrow. This is x. That's for if you're reading some memes. Okay, variable. This is practically what we call in English, this is what we call the unknown, right? Or I think in mathematics in general, we call this is the x, right? I'm usually just write x, but sometimes it's not the x that we know. So it can be like that. It can be like that. Okay, but some textbooks, some writings have different x, but that is the same unknown x. Okay. So what is x? Is actually if we say 2 plus something missing and it's equal 5, we know that this something is 3, and this something is what we call x. Okay, so that is what we call x here. So 2 plus x equal 5. So x is 5 minus 2. It's 2. It's 3, right? Okay. Just a simple algebra. And we start I think the very one of the very basic of the algebra is the polynomials. Okay, the polynomials. Although we are going to have another section that is dedicated to polynomials, but let's say we are start from these algebra expressions with polynomials. Okay. Okay, that's the polynomials. Okay. Okay, so polynomial, of course, is a variable in the expression of the form that we have power n. Okay, and it can be in any power of n. It can be power of 5, 6, or any high power. Okay. Okay, you can see the definition over there. I think it's quite complete, and I don't want you to memorize this. Okay? I don't want you to memorize this. I want you to understand. Okay, now how to multiply the algebraic expressions. So if I have this, so this is two different expressions. And we call this is one way, it's another way, and if we want to multiply these two, how do we multiply? So we just usually if you want to like step by step, you take each of them, right? Multiply with another one, right? Let's say we start from this one. Let's say this is multiply here and then multiply there, right? And then 3 multiply with x squared and that, right? And we say that, okay, we are going to multiply 2x. Or if we want to, like, step by step, let me write the whole thing here. And then plus 3. Okay. And then we can take that to x cubed. Okay, and then we check this with the same components, that has the same components, right? So we get, right, this 2x cubed minus 7x squared, and then minus 7x, and then plus 12, right? That's one way. Sometimes you can also, maybe let me put there first. Let me make it small. Sometimes you can also make with a table, like so this is multiplication. You can do this also. Well, it depends on you, which one you prefer. It's the same way, 3x squared minus 15x plus 12, right? And then this will be 2x cubed, 2x cubed, and then minus 10x squared, and then plus 8x, and then plus. And in the same way, same results. Okay, some special product formulas that usually we are going to have. We have this a squared minus b squared. We can factor out, becomes a plus b, a minus b. Okay. We can have the a plus b squared, and it means that we expand the forms. It becomes a squared plus 2ab plus b squared. I believe I don't need to prove this, right? A minus b squared, and this will be the difference is just minus here. The same plus b squared is positive. And then sometimes we need to cube of sum and cube of difference. And we have 3a squared b, 3ab squared plus b cubed. Okay. Some special forms. I think you can also take this into the geometric perspective. Okay. Sorry. In geometric perspective, then you have a square with a, and then you multiply, become a squared. Okay? And you have additional b and additional b. So you can take a plus b, multiply a plus b, which means a squared plus 2ab plus b squared. Okay? This is also, I think, very intuitive proof in geometric perspective for the expansion for this square. Okay? Means that you can, from here we can take okay. Okay. And then we can have the factoring. So the factoring means we are going to reverse the product from the previous one. So if I have this is factoring, this is expanding. some special forms that we might need in the future. So a squared minus b squared, as I mentioned, you can have this a minus b plus b, and you can just try to multiply, and you see that this is going to be a squared minus b squared, right? So whenever you see any a squared minus b squared forms, that you say you can factor in into this form, okay? And then if you have this perfect square like this, it means that you can make complete the square, right? And then the same thing with the negative, you can have a minus b. And sometimes this is also useful. You can factor out a minus b from the a cubed minus b cubed. You will perfect the a squared plus ab plus b squared, okay? And the same thing with the a cubed plus b cubed, you can have the a plus b. Okay? Factor out from the forms. Okay, let's check the factors. Can you factor it? Can it be factored? Yes, right? How can you find the factor? Yeah, one way. Oh, really? Okay. So let me help you. I don't know if my method is not suitable, but let me show you how usually I find. So usually I will make it a table like this. But not really necessarily a table, but just like to separate this tree. And then put the numbers that is possible to make multiplication with resulting the 6x squared. For example, maybe x 6x or 3x 2x, right? Any other factors? I don't think so. I think we can take maybe 2x, sorry. 3x 2x, it will be 6x squared. And then focus on, maybe let me use different color to make it clear. And then one in here. So we have to think on a number that when we multiply this, it will result in -5. So I think the common factor is just 1, 5, right? So -1, 5 or -5, 1, right? So we could try, let's say, maybe -5, 1, okay? And then what we are going to do, we are going to cross multiply this. Okay. So 3x minus 10x, it's -7. So we need to switch, right? So we are going to take this and multiply with this. And now we have the correct one, right? We have 2x, -3x, and then plus 10. So plus 10 minus 3 is 7. So this is our factor. So we can write that this will be equal 3x plus 5, 2x minus 1. Okay. If you want to follow this method, that's okay. I think there are other methods as well. And this 3, I know 3, but I prefer this one. Okay. So sometimes if you feel nervous in the exam, then sometimes you can factor it out, and then you try some numbers, but you don't think that it's working. Maybe making this table, and then it will make a little bit more set up, right? So you can have, like, you can be more relaxed. Okay. Okay. Okay, let me change this and move a little bit to. I prepare some discussion part actually for today. Let's go to here. Okay. So. Okay. Let's try one by one. Okay. I think you can try either number 2 or number 3. Number 1 is too easy. Number 2 or 3. This is for warm up. Okay. But if you think you're confident, you can skip. Okay. Or if you want to like warm up, like maybe you're maybe not really having maths for some months or maybe years, then you can just try to warm up.
For this one?
Mhm.
Does this go to like here and here? Or can I do it like that?
What do you think?
Like langsung gini-gini kan maksudnya? Sorry, right?
Maybe. Yes. This one. Where's Y?
I mean, expected
check.
part two, Y to the part
Yeah.
two. Yeah.
Yeah. Don't remove the Y. Okay, group 4 or 5. Do you want to try? Okay, do you want to try? 4 or 5? Group 4. Who is group 4? Anyone to try? Maybe here. Okay. And this one is for the number 3. Okay. Still right? Anyone? It means simplify means like you what? Which one, left or right? Maybe you can choose. Okay, okay. Okay, okay. Okay, good. Group 5? Oh, yeah, yeah. Marker? Group 5? Yes, right? It's okay, it's okay. Maybe some steps. Okay, let me just start with the first one. So I'm skipping that one. So this will be equal, so x squared, and then 16 x with power of 4. So this is 16. 2 plus 4 minus 3, which means 3, right? And then what's happened here is, let me just write the cubic roots. And then let me square this x cubed y. It's x 6 y 2. And then y 4. And then this will be x6 and y6. And this will be x squared, y squared. Okay, we divide by 3. Okay, that's okay. 3 over 2, okay, okay. I think half 2. Oh, okay. This 2 and half should be 5 over 2, right? Okay. Let me show you. Okay, let me show you. So this will be equal, or let me just write, and let me make all in the top one. Okay. So I will write 8r. Or you can maybe start with taking 8 by 2, it's 4, right? R. And then you have half. And then you can make R 2 S minus 3 S minus 4, okay? And then this will be 4 R. Half plus 2 is 5 over 2. And then you can write s with negative 7 like that, or you could write and then over s with power of 7. Okay. This should be okay. Anyone still thinking on the process? Okay. Okay. Anyone still have any confusion? Okay. So what's the idea? The idea here is every time you see any denominators like this, is if you want to take to the top, then it will be reciprocal. So which means that it will be -3. Okay? Like this one here. It's 2 plus 4 minus 3. Split 3 like that. Okay, I prepare another questions. So this question before we end the lecture, okay? I think the next page will be the last one, okay? And then we can finish. Okay, let's go to the next page. And this will be the factor. I think the first one is easy. You can start with the number 2 entry. Uh, 4, 5. Group 6 and 7. Each one of the groups should try. Okay, so let me just rephrase the beginning of the course that we have the groups. What I want to do with the groups is starting from next week, you need to sit within each groups. So, and the order should be up to you. If you want to, then 1 over there, and then 7 over here, and then you can try maybe 2 to 5 there, and then it's not necessary to be in order, but you need to be within your group. Why? Because first, most of you are new students. You need to get to know at least your friend, or if you are not really liking having a friend, at least nice to know someone, right? Okay, group 6 or 7, which one would you like to try? I want to know which one is group 6. Who is in group 6? Only 1, 2? Only 2? How about 7? Who is 7? 1, 2, who else? 3? Okay. Okay, group 6. Do you want? Okay. Okay, right here. Right here. Just right. And how about 7? Who would like to try? Okay. Who would like to try? Yeah. You can try to calculate in front if you want. Just like her. I think she's pretty doing good job. Nothing to be afraid of. You will do the same with the paper and the board, right? Or you feel pressurized, no problem. Just go front and calculate something. Okay. Thank you. Okay. Okay, good. Okay, the last one seems off, right? But what will or what should you do with if you get this? Skip it. Skip it. Okay. Anyone? Group 7?
You make this?
No, the group 7 first. Group 7 first. Yeah.
Hey, if y'all don't go, I'm gonna go.
Okay. Good. Wow. Good. Good. Good.
But I don't know anything.
Try. We'll give you a clue.
The thing is, if it's 1/2, then it's gonna be a square root, or if it's...
Mm-hmm. But what's the question? It's factor the expression.
So like,
So
make
you
it
need to-
simplified, or like,
Make it. Can you make it like square?
wait,
How do you make it?
how do you make it square?
Can you factor out something from there? Can you
3
factor
over
out?
2?
Yeah, you can try. 3 over 2 or 1 over 2. Try that one as well. Mm-hmm.
I gotta write it again. So this would be x. And then this is. But if it's minus minus, does it count as like? Can it be a minus in front of the square root? Is it okay? Not inside, right? Inside it's possible, but
I
impossible.
don't know. Can you try? Well, what I'm giving you.
If it's a minus, then.
My clue is you need to factor some variable or some components from this. Can you factor out half x with power of half or x with power of negative half?
Because I'm very bad with like I still don't grasp the like how do you say it? Like the idea of like the half, because I just know like half is the square root of it, but then I don't know.
Okay. Anyone? Anyone who can? Okay. Take these come
The answer is
first.
extreme. Well, I don't know what I did with this.
It's 3 over 2, then it's 2 over 2, it's just 3 over 2.
We have to send this down.
Yeah, you need to factor out.
Oh, that's.
Yeah, you need to factor.
Oh, so you gotta factor out
Which you can do it on the maybe here.
I got no idea.
Okay, you can sit down. Okay, can you try over here?
Maybe for this point, minus 3 over 2.
Okay. Mm-hmm. Yeah, almost. You can finish this off.
Just make the minus shape on
Yeah,
the
yeah.
right side.
Yeah, I mean, this one is,
Yeah.
you can factor it.
Factorize it. Like
Yes!
Yeah, can you just do this right?
Yeah, it's
multiply by the power of x.
No, multiply. Multiply. But you are going to factor out this. Like, I mean, factor out this, and then this will be this. And then you can factor out this.
Oh,
Right? Okay. And it's already set.
oh yeah.
Yes. Yeah. Yes. So you want to remove this part?
Oh.
Not remove. I think you need to just factor it. Yeah. Right. Until here, then you can factor this one. And that's it. Yes. Yeah, 3. And then 2x become just a normal one. Right? No need to be equal to 0. No need. We don't go there yet.
I just wanted to find it by form, not form.
I think you said something.
The theta?
Yeah. Is this one?
Oh, wait.
Yes. Yes.
Then can that equal?
The one that before. Which one?
I mean, I first I want to find
Yes, true. I mean, not factor out with this, but I think with the minus half. 1 over square root of x, right?
I mean, just
Yeah. So that the other factor will be this one. So you can factor this, and then that's the answer. Yeah. Yes. That's the one I need. Okay. Finish? Before it's almost okay. So okay, what we have here. Let me rearrange this. Okay, you can sit down. You can sit down. Okay. But your idea is okay, I think. So let me rewrite this. Okay, and then what we are going to do is we want to make all this power become something that is recognizable. How do we are going to do that? We need to factor out something out of this 3 components. Okay, so we are going to take out. You can try maybe x with power of half, with power of minus half, or anything that you can think from these 3 components. Okay? So what I want to do is I'm going to just taking, okay, so that we have this is going to be what? 5x cubed, right? Okay. Plus 2x squared minus 3x. Okay, and then we can take this component here, and then take this x outside, Oh, wait. Wait. Okay, first that is the first one. Okay. And then we take the one. So this will be 5x squared plus 2x minus 3. We can factor out this, become 5x minus 3 and x plus 1, right? And then we can take this with power of negative half. So we can check 5x squared, this is going to be there. And if we multiply with negative half, that will be right? Okay. So 5x squared. Oh, we need to move with another x. We need to apply the another x. Wait. So this will be x half 3/2 Wait. Should be half, negative half, right? Negative half.
Sir, isn't it supposed to be what, minus 3 or minus 1?
Yeah.
Minus 3x power of 9. Yeah. So you put the x or 1 over the other. Yeah, that's what I'm thinking. That's what I'm confused about. Where's the minus 1?
Oh yeah. Why I'm missing that this point? Okay, and then yeah. I know. It's getting late. My brain getting lazy. Sorry about that. So this will be.
I don't know, guys. It's like a little bit of explain to us. Where is it at?
I think let me just erase this. Okay, this. Okay. 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 Negative half, 2, 3/2, right? Okay. 1, negative half, 1/2, correct, right? Negative 3. Okay. Okay. Now why I did that mistake? Okay. Sorry. Okay. So then you can factor out this, and you get 5x minus 3. Actually, the negative positive makes things confusing. It makes sense. Right, okay. I'll say so sometimes you need to find a way to make out this form.
Y is that when you take out x plus 1 over 2, and that's 2x. What is that? Because it's multiplied on 2.
Que tiene que ser todavía.
Sí, estoy seguro, pero no. ¿Y por qué te dije eso? ¿Por qué te sigues eso? Yo no hablo inglés.
Yeah, the one that makes confusing is the positive negative.
The other two terms.
Yes. 1 minus
I got it.
1 minus half. 2 minus half.
Because we times it with 1. So we
Wait, hold on. That's right.
Oh wait, do we plus it? Are we plussing it or are we? Wait, hold up. Wait, hold up.
But wouldn't it be negative then, Mr. Iman?
Here.
So
5x.
and I fixed it.
Okay. Thank you. Okay, now you see the complications. Okay. Ready? Okay, right? Okay. So remember the exponents. So, yes. Like if you have a and you plus this, right? Okay. If you have a m over n or a with m and then a negative n, it means that you minus it, right? Okay. Okay. Get it? At the middle, I also have the same problem. Why I did this?
Oh wait, yeah, wait.
You get it, right?
Yeah,
So this is the low exponent.
I got two.
So negative half, you factor out this, then you have this. Because if you want to like prove it, then just multiply. So this x with power of 1, which is 2 over 2. 2 over 2 minus 1 over 2 brings back this, right? This is, we just multiply. This x squared, we multiply with this, it means that 2 minus this, right? So 4 over 2 minus 1 over this, which is 3 over 2, okay? Yes, sometimes a very simple thing in the mathematics when you are combining with. Okay, I think I will end the lecture. Okay, I will end the lecture and then see you in other courses. Okay.